So yesterday we started talking about LANs, which are local area networks, and we covered kind of topologies and a few different types of cable. And today we're going to carry on talking about the hardware that's involved in LANs. So the first and probably most important part of networks, and something which we can't really function without, is something called a switch. And it's used in a star topology mostly, and what it does is it provides a central point of connection for all the wired nodes on a network. Okay, so it's a central point of connection for all the wired nodes. So the UTP cable, as you can see in this image over here, goes from each of the computers to a central location called a switch. And they look like this. I did show you a picture of that recently. And you can see that all of the different cables go into these switches. And these switches can in turn link to other switches, which can link to other switches, etc., etc. So there are a bunch of these on the network. And these devices are quite clever, because what happens when your computer sends a data packet along, it contains a bunch of information, and one of the pieces of information that it contains is the MAC address. And we spoke about MAC addresses yesterday. It is a unique address which is hard-coded into the network interface card. And why that's so important is that most of your modern-day switches look at the destination of the packet. So if you send a packet from one of these computers on the network, it will reach the nearest switch, and that switch will say, where is this packet destined for? What is the MAC address? Where is the MAC address? Because the switch keeps track of all the MAC addresses of what's connected to it. And if the MAC address that is in the packet is connected to that switch directly, in other words, if we send a packet from one of the computers in this lab to another one of the computers in this lab, the switch will send it directly there. It won't send it to the rest of the network. It will just send it straight to the computer. If the MAC address is one that the switch doesn't know, it will send it to the next switch that it's connected to. If that switch recognizes the MAC address, it'll send it on. If it doesn't, it'll send it to the next switch. And the reason that it does that is that it prevents traffic, network traffic, from going to segments of the network unnecessarily. So if you're trying to communicate with your computer in your house or in your dorm from the lab, then that MAC address will be registered, and when it reaches the switch that the lab computer is connected to, it will say, do I recognize this MAC address? If it doesn't, which it won't because it's in your dorm, it will send it to other switches until it gets to a switch that recognizes that MAC address. If you send it to another computer in this lab from within this lab, that traffic won't be sent anywhere else in the network except within this lab. So switches are very important, and like I said, most modern day switches are absolutely vital because they keep traffic from going to places where it's not necessary. The next piece of hardware is called a repeater. Now, yesterday we spoke about attenuation, which is signal strength which weakens due to distance. And all that a repeater does is when it receives a weakened signal, or any signal, it amplifies that or regenerates that and sends it back on. So that can extend the length of a network cable, for instance. So if we absolutely had to use UTP for longer than 100 meters, we'd put a repeater within those 100 meters, and it would boost the signal. A lot of switches do contain repeaters built into it. So you don't often find a repeater just on its own in modern networks. Okay, the next thing we talk about is a bridge, and a bridge really separates two network segments. So you can see by this image here, we may have one network segment over here and another network segment over here. And a network segment really is a part of the network where most communication happens within that part. So if you think about it of your, let's say, the bursary. The bursary has its own server, so a lot of its network traffic will just happen within its segment. If it needs to go out of that segment, it'll have a bridge, and the bridge really controls whether that's going to leave that network segment or not. They're not very commonly used, largely because your switches have now taken the place of those bridges. So don't spend too much time learning that. It is just something that you need to be aware of. And here's another diagram. If all the communication happens in segment 1, the bridge will prevent that data from going out to segment 2. So it's all to reduce network traffic. Now, this is a very, very, very important concept. It's probably after switches, it is one of the most important concepts that there are in computer networking. And this little device is called a router. And what a router does is it connects two networks using the same protocol. Now, we'll talk about protocols a bit later on, but essentially what a router does is it routes traffic between networks. So the MyClass network is one network. Okay? We only have one or two routers, and the purpose of those routers is to route our network traffic outside to the internet. Okay? So routers are used to route traffic from one network to another. And they have something called routing tables. And what happens is when a piece of information is sent on the network, so for instance, if you're surfing the internet from your laptop, the destination of that data packet will be an external IP address. So it'll be an external address on the internet, and wherever it goes on the network, each of the switches will go, this isn't an internal IP address, we need to send it to the router. So it'll eventually land up at our router, and our router, which connects us to the outside world, which is essentially another network, will say, right, the destination is Instagram or Facebook, where the router decides where to send that packet next. And often where that packet goes is to your ISP. Okay, so you can imagine that the router will route the traffic from our network to our internet service provider. From there, Vodacom or Internet Solutions or Web Africa or whatever ISP you're using, they will have an even bigger, more advanced router. And that will know, its routing table will know where to send that to. So if it's a US address, it'll go, right, I know that the route to the US is this is the next stop. So I send it on that path, and when it gets to the US, it goes, okay, I know where the route to this address, and eventually it'll reach Instagram or Facebook's server or whatever the case would be. So a router is a very complex device, but really the definition of a router is to connect individual networks or connect separate networks using the same protocol, TCP/IP in this particular case. So here's a nice diagram. You can see this will be the internal network. Okay, so we'll have a switch connecting a database server, a printer, a desktop computer, a laptop, whatever the case would be, and then a router which connects us to the internet. Okay, and the router will then go to the internet service provider, and the service provider will have routers of its own which connects to other networks, and it will know exactly where to send that. Okay. Next, we go on to what we call media access methods. So what we've done is we've gone over the hardware and the cabling and the network interface cards and routers and switches. And now what we want to talk about is how exactly does your computer access these wires that it's connected to, or any medium that it's connected to. So obviously your computer, your device is sending out electrical signals on a cable, or it's sending out radio signals if you're using wireless. How exactly does every computer on the network get access to this cable? Can anyone just send at whatever time they want it to? And the answer is we use media access methods. Now, a lot of you will know what CSMA CD is, or you'll know about other access methods, but you won't know the term media access methods. So in an exam, when you see the term media access methods, this is what it's referring to. Now, the most common and the one that pretty much the only one that you really need to know in depth is called CSMACD, and it's the most commonly used in wired networks, in local area networks. And CSMACD stands for Carrier Sense Multiple Access with Collision Detection. Okay, and the way this happens is you have a whole bunch of nodes on a network which are wired. So let's take the computers in this IT lab. And when one of them wants to transmit something on a network, it firstly listens to see if there's any existing traffic on the network. If it's quiet, now that's the carrier sense part. So it listens to see, is the medium clear? Is there any other traffic on this medium? Okay. If it is clear, it will attempt to transmit its data. Okay. So all the nodes have equal access. So any node can start transmitting once it's determined that there's no other data on the wire. What it does, after it has started transmitting, it detects a collision. And if it detects a collision, it will wait a random amount of time and then attempt to listen to see if the medium is clear again. So if we can use an analogy, let's say, for instance, there was no such thing as raising your hand when you wanted to ask a question in class. So what everyone in the class would do is they would first listen to see if anyone else is talking, and then they would start speaking. But anyone can start speaking. And if two people start speaking at the same time, they would immediately both stop and then wait a random amount of time before starting the process over again. So student A and student B want to start speaking together. They both listen. Then they start to speak. If they start to speak at the same time, they both immediately stop speaking, wait a random amount of time, listen again to see if anyone's speaking, and attempt to start again. Now, it's important that they wait a random amount of time, because if they were waiting the same amount of time, they would just start speaking again immediately, and there would be another collision. Okay? And then no one would ever be able to speak, because you would all start speaking at the same time, and then stop, and then start speaking at the same time again. But if you wait a random amount of time, then student B would start speaking, and then student A, after his random amount of time is over, would listen, hear someone speaking, and stop. Okay, and wait till the medium was quiet. So that's what it means when it says carrier sense, listen to hear if it's clear, multiple access, anyone can access it at any time if it's quiet, and then collision detection is quite important, because you have to note whether your packet has collided with another packet. So CSMACD is not really necessary with most newer switches, because everyone has their own unique cable going to the switch, and the switch can then store that and then handle the collisions and the access from there. But that's generally how it works. Okay. Token ring access is quite old. It's not really used all that much anymore, but you can read through it just so that you know what it is. Essentially, it consists of a token which floats around a network, and you can only speak if you have that token. Okay, so you put your data on that token that goes around the network. If there's something on the token already, then you can't use the token. You have to wait till the token is clear. You can reserve that token though. So let's say it's going around and it's going around, and student A puts something on the token, and then it gets passed around to whoever it's going to, let's say student Z. If student P wants to use the token, it sees that it's busy, because student A is trying to communicate with student Z. But what it can do is reserve the token, so student P says, I'm next. So the token will go around, it will reach student Z will take the message off, which is for him, it'll then go around again, and then everyone can see it's reserved. Eventually reaches student P, he goes, right, it's my turn, puts something on the token, sends it to student, let's say, C, goes around again. So that's what token ring access method is. Then we have, and those are really the two main ones. You really just need to know CSMACD. So what we talk about next is LAN technology. So we've spoken about the different types of hardware, we've spoken about the different types of media access methods, we've spoken about the different types of cable, topologies, star and ring and bus, etc., etc. There are a whole bunch of different topologies. Now, what we talk about now is LAN technologies. And what LAN technologies are is they're kind of packages which have been set up, okay? And the most common one is Ethernet. And what these LAN technologies do is they standardize on a topology, they standardize on a cable type, they standardize on a media access method, on transfer speeds. And what they do is they bundle them all together and they call it a technology. So they say these are the kinds of things that work best together, and this we're going to call Ethernet. And Ethernet standardizes on a star topology or a bus in older networks. It standardizes on twisted pair cable and fiber optic. It uses CSMA-CD and it speeds up to 1 gigabit per second. And this is tried and tested. We know that all of these things work really well together. Okay, so we call it Ethernet. And that is why Ethernet is used so commonly. Is because we know that it works. We know if I tell you this is an Ethernet network, you know it's going to be a star topology, it's going to be using twisted pair, it's going to be using CSMA-CD, and it's going to be speeds of up to 1 gigabit. So I can take you to any Ethernet network and you'll know that that is the case. So you don't need to worry about anything else. The advantage of that is that's why they call it an Ethernet card, because the network card is going to take a UTP cable, it's going to use CSMA-CD, and it's going to use speeds of up to 1 gigabits per second. Okay, that's what we know an Ethernet card is. It's made to work with those cabling types, with that media access method, with that speed, with that topology. So Ethernet is just a collection of these things which we've just spoken about. Okay. So that's one of them. The other one is called FDDI, which is Fiber Distributed Data Interface. And that's used for fiber networks. And it's usually used for a fiber backbone with a token ring going on the outside. Now, all you really need to know is this is used for large areas of network. Okay, and it uses token passing, fiber optic cable, and a ring topology. In reality, if they ask you what kind of a network technology will be used to connect this very large area network, say FDDI, okay? Even though it's technically not correct, just say that in the exam because that's the answer that they're expecting. Usually what we use for fiber backbones is generally a bus topology, but you know what? Just say FDDI is the one you want to use.
What's the question?
If they ask, the question that they'll ask in the exam is, which network technology would you use to connect these buildings which are very far away, or which technology will be used for the backbone of the network? Just say FDDI. Okay, it's just the safest. Right, so then they get on to the physical limitations of a LAN. And obviously the biggest physical limitation of a LAN is the distance that it needs to cover, because you're limited by the length of UTP and fiber and all the rest of it. And you're also limited by the number of workstations attempting to access any one particular area of the LAN at a time. Sorry, just... but generally, we can split LANs up into subsections or subnets using switches and bridges and the things we've kind of talked about up until now. Okay, so that's pretty much for what we call bounded media. Now, when you see bounded media means wired media. So it means wired networks. So unbounded media is what we're going to get into the next session. And then we talk about wireless LAN. So if you ever see the word unbounded media means wired networks. And we're usually dealing with LANs and Ethernets, maybe with a fiber backbone, star topologies, all the kind of things that we've discussed up until now. So that's it for bounded media. So please keep that in mind when you see the word bounded media, and it largely revolves around Ethernet. So in the next section, what we'll do is we'll cover wireless networks, which are obviously very relevant and often examined these days because they're so common. And what I will also do is I will upload a video of a tour of the MyClass network. Okay, so I'll take my cell phone and I'll go on a little bit of a walkabout, and I'll show you how things are connected from the lab all the way through to the switches in this office, all the way to the switches in the server room, and where the fiber optics go to, etc., etc. Okay, thank you.